Alright guys, so today we're going to be talking about solving rational equations. We've done a lot of math so far, like yesterday's quiz. You guys demonstrated your knowledge of adding, subtracting, multiplying, and dividing rational expressions. Now we're jumping into equations. Equations mean something is set equal to another value, therefore we can solve for the variable. As a little bit of a warm-up, I wanted to review just, basics of solving equations. So, if we want to do some of these equations, what I would suggest is maybe pausing the video now and then hitting play and reviewing the work I'm about to do, see if you can solve these on your own. Alright, so if we want to solve some of these problems, this first problem we would have to use a distributive property to start off. So we're just going to review the basics of solving equations today. We have 15x minus 10 equals 16x minus 4. Now, whenever we solve an equation, our objective is to get all the variables on one side and all the constants on the other. So in this equation, it doesn't really matter which way we move our variables, to the left side of the equation or to the right-hand side. What I like to do is I always like to move the smaller amount of variables because then I know I'm going to keep the coefficients positive. And simultaneously, I'm going to add 4 to each side. And we'll have negative 6 equals 1x, or negative 6 just equals x. So that's our solution to our first problem. Negative 6 equals x. Now, problems 2, 3, and 4 are a little bit more what we're going to be looking at today, because 2 and 3 require solving quadratic equations, and number 4 is going back to review our addition with rational expressions concept. So for number 2, we start off by distributive property. We rewrite the equation as x squared minus 4x equals 3x minus 12 plus x. From here, our objective is to get all our like terms combined. And we're going to try to get everything on the same side of the equation. So, if I want to get all my like terms on one side of the equation, what I'm going to do first, I'm going to combine 3x and x to be 4x. So I'm going to rewrite this equation over here to be x squared minus 4x equals 4x minus 12. Now, this is a quadratic equation. The reason why I know it's quadratic is the fact that it has a degree of 2. Whenever we have a quadratic equation, our objective is set the equation equal to 0, and then we'll solve through factoring. So we're going to move everything to the left-hand side of the equation. When I say move, we're going to use inverse operations to move things to the other side. We'll have x squared minus 8x plus 12 equals 0. Now, to solve this problem, we have to do some factoring. Factors of 12 that add up to negative 8. Those factors would be x minus 6 and x minus 2, because negative 6 and negative 2 multiply to be positive 12 while adding to negative 8. Again, if you need to review factoring, look back. Ms. Furman posted a good video the other day about factoring, but there are tons of resources on factoring as well as the resources we provided in class to you guys. So we get x, lastly we get x equals 6 and x equals 2 by setting each of those factors equal to 0 and solving. Number 3, we're looking for factors of 24 that add up to 5. So again, just to review that concept, what I'm really doing is I'm looking for something that has a product of negative 24 and a sum of positive 5, our product sum table. So something that multiplies to be negative 24 and adds to positive 5. Those factors would be 8 times negative 3 and 8 plus negative 3. 8 times negative 3 is negative 24. 8 plus negative 3 is positive 5. My last step is I set each of these factors equal to 0. And we get x equals negative 8 and x equals 3. Lastly, we review adding. When we add our rational expressions, we want to make sure we have common denominators. The way we get common denominators is I'll rewrite it over here. We're going to multiply or rewrite each equation to be an equivalent expression. So, my least common denominator will be 10x. I need to multiply my left fraction, top and bottom, by x. And I need to multiply my right fraction, top and bottom, by 10. This will create fractions with the same denominator, therefore we can add them together. X over 10x plus 10 over 10x. Notice now we have the same denominator. Because we have the same denominator, I'm able to add this together to be x plus 10 over 10x. That is my final answer. There's no more simplifying to be done there. When we solve rational equations, the definition of rational equation is an equation that contains rational expressions. One way of solving rational equations is to use cross multiplying. So if I have a single rational expression, that means I just have I'm going to say things like a fraction, even though it's a rational expression, but hopefully you guys notice that it looks like a fraction. If I have a singular fraction on each side, we can cross multiply. So b times c is bc, and a times d is ad. We're going to use cross multiplying to solve. The next example, we're going to use cross multiplying to solve. All right? Before we get into solving, though, we're going to look at this concept of undefined. Sometimes x might be undefined. And what we mean by that is anytime a number makes the denominator 0. So we look at these three examples. Where is the expression undefined? It will be whatever makes the denominator equal to 0. So a lot of this you can solve with mental math. But the way you can show your work is you just set each denominator equal to 0. On my top example, if x plus 4 equals 0, if x was negative 4, negative 4 plus 4 equals 0. If x was negative 4, that rational expression would be undefined. Remember, I can never have 0 in the denominator. So if x was negative 4, I would have an undefined expression. Likewise, in the example number 2, if x was 5, I would have an undefined expression because that would cause a 0 in the denominator. Lastly, if I wanted to solve x squared minus 4 equals 0, it might help to factor using my difference of squares first. By factoring, I see x minus 2 times x plus 2 equals 0. And through factoring, we set each factor equal to 0. And we get x equals 2, x equals negative 2. In example 3, if x was positive 2 or negative 2, the function would be undefined. Well, now that we went over the concept of something being undefined, let's actually get into solving. So we're going to solve this equation by cross multiplying. First, we're going to identify what x cannot be. So put a little separator there from the problem from above. I want to make sure that x cannot be the values of x can't be 2 and x cannot be 5. Why did I come up with those two values? If we look at the first rational expression, if x was 2, this would have a denominator of 0, which is no good. We can never have a denominator of 0. Likewise, 2x minus 10. If x was 5 in my second rational expression, that would have a denominator of 0. That also is not allowed. So x cannot be 2 or 5. Well, let's try to solve this expression out. We're going to do this by cross multiplying. So I like to draw those arrows in to indicate cross multiplying. That means our new equation is going to look like this. And I'm not doing any of the multiplying. You guys might be able to do some of it in your head right away. But right now I'm just showing what that cross multiplying looks like. It's 7 times 2x minus 10 and 11 times x minus 2 for that other diagonal. Now we'll solve. This is like the first warm-up problem. We will distribute and solve algebraically. Distributive property, distributive property. 14x minus 70 equals 11x minus 22. Our next step is to get all of our x variables to one side and all of our constants to the other. So I'm going to subtract 11x from each side, and I'm going to move this 70 to the other side. Rewriting my equation, 14x minus 11x is 3x. Negative 22 plus 70 is positive 48. Last, we'll divide each side by 3. And we get x equals 16. This is a good solution because it does not make the denominator 0. 16 is okay. We'll show an example later on where what happens if we get the same value as an answer as our undefined values. But we'll cover that in a little bit later problem. So x is equal to 16 for this example. Our next example is solving a rational equation by first finding a common denominator. This step is required if we have more than one rational expression on a side. So if you look back, this first example had a single rational expression equal to a single rational expression. But if I have more than one on the left or right hand side of the equation, that means I need to solve by getting a common denominator for every term first. So this kind of picks up from where we left off on before we did our first quiz. We know how to find common denominators. So let's find a common denominator. I have denominator of x, denominator of 5, denominator of x. My least common denominator will be 5x, or it's really the product of this denominator and my other denominator. But my least common denominator is 5x. So how can I change all my fractions that have the same denominator? We're going to multiply to create equivalent fractions. Remember, when we multiply, same on top and bottom. So by multiplying 15 over x by 5 over 5, I would get 75 over 5x. I have to multiply this middle term by x over x. And I have to multiply my last term by 5 over 5. And we would have plus 4x over 5x equals 35 over 5x. Notice everything has the same denominator. Now, that's great. Now we get to do this really great trick. When everything has the same denominator in a rational equation, we get to just cross out all the denominators. So that's a really cool shortcut you guys get to do. If everything has the same denominator, but it has to have the same denominator first. I couldn't do that in the original problem because they had different denominators to start. But once everything has the same denominator, you can cross out your denominators and rewrite your equation as just the numerators. And now we're going to go ahead and solve. So to solve, we'll subtract 75 from each side. We'll get 4x equals negative 40. Divide each side by 4. I would get x equals negative 10. And that's how you solve an equation, by finding the least common denominator. We have two more examples to look at. How to solve an extraneous solution and how to solve an equation with two solutions. Remember that word extraneous, what it means. Extraneous just means we would get a solution, but like when we solve algebraically, we're going to get a value. But that solution may not fit into the given parameters of an equation. Like in a real-world situation, sometimes we might solve for length, and we may get a negative for length. Well, since we can't have negative length, we sometimes call that extraneous. Let's look at this problem in the context of extraneous. Right away, I want to look at what x cannot be. Well, what will make my denominator 0? If x was 2, my denominator would be 0. So right away, I'm going to make a little note that x can't be 2. Because if I had 2 in this denominator, it would be 8 over 0, or I would have 8 over 0 again on the right-hand side. I can never have a 0 as the bottom of a fraction. So x can't be 2. Keeping that in mind, let's go ahead and solve this. I have more than one expression on the left-hand side, so I cannot solve by cross-multiplying. I must solve by finding common denominators. The least common denominator, I'm going to put 3 over 1, by the way. My least common denominator would be x minus 2. Notice, this already has the right denominator. So does my second fraction right here. I really only need to change that 3 over 1. That have the same denominator as the rest. So let's start with that. So we're going to need to multiply the top and bottom by x minus 2. Rewriting that fraction, we have 3 times x minus 2 over x minus 2. And look what we have now. We have everything with the same denominator. And we like that because we get to do this trick now. Same denominators, we have to cross them all off. Now we don't have to deal with fractions anymore. Now we're just solving a regular algebraic problem. I went ahead and distributed the 3 into this parentheses. 3 times x minus 2 is 3x minus 6. So now I have 3x minus 6 plus 8 equals 4x. Let's solve this equation. I can combine my like terms. Negative 6 and 8 makes a 2. I'm going to subtract 3x from each side, leaving me with 2 equals x. All right, we solved the equation, and we got 2 equals x. But what did we say in the beginning of the problem? X cannot be 2. Since x cannot be 2, this is an extraneous solution. Therefore, this problem wouldn't have a solution anymore, right? Because this does not work in the given parameters of this equation, all right? My question, by the way, today, you'll see it, is going to be, what did Mr. Purdy draw in the top corner of his notes? And it's going to be a smiley face. So make sure you're going to answer that question for credit for watching this video, all right? Don't be too harsh on my art skills. All right, now we're going to solve an equation with 2 solutions. This is going to be related to example 5 and 6 on your homework problems tonight. So keep that in mind. This last example is going to go with 5 and 6. We're going to get an equation with 2 solutions. First thing we're going to want to look at is, are there any values that x can't be? Well, x can't be negative 7 and x can't be 0. Again, that's what would make my denominators have a denominator of 0. X can't be 0, x can't be negative 7. Now we'll go ahead and solve this. Once again, I'm going to have to solve with least common denominators because I have more than one term on the right-hand side. So let's first find the least common denominator. My least common denominator, and this is 1 over 1. Every number, if it's a whole number, has a denominator 1. So my least common denominator is x times x plus 7. That would be my least common denominator. So I want everything in this problem to have the same denominator. So let's go about changing them. My first fraction on the left-hand side, I have to multiply by top and bottom by x to give it that common denominator. This 1 is going to be tough to squeeze it in, so I'll just write it underneath this. We're going to have to multiply by x times x plus 7 and x times x plus 7. My last fraction, this 12 over x, we're going to have to multiply by x plus 7 on top and bottom. I know that looks a little cluttered and confusing, but what we're doing right now, just to explain ourselves, is to get everything to have the same denominator. By doing that, I can rewrite my problem as 12x over x plus 7 equals x times x plus 7 over x times x plus 7 minus 12x plus 7 all over x plus 7. A lot of writing to get to this step. But the reason why we got to this step is this great trick we get. Same denominator, same denominator, same denominator. All right, we're out of the fraction realm now. We get to cross out all the denominators. And I know how much you guys like to leave fraction land. Now we're going to go ahead and solve this equation. I distributed this x to be x times x is x squared. X times 7 is 7x. Now this next one, be very careful. We're distributing a negative 12. Negative 12. So my next distributive property should result in negative 12 times x is negative 12x. This is the one a lot of people forget. negative 84. Negative 12 times 7 is negative 84. All right, quadratic equation. What's that mean? We need everything set equal to 0 in order to solve, because then we're going to solve through factoring. So we're going to combine our like terms as well as minus 12x. (7x minus 12x minus 12x). 7, negative 12, and negative 12. That combines to be negative 17x minus 84. Now we're going to do some factoring. I need to come with factors of negative 84 that add up to negative 17. So to go back to your factoring, that looks like this. Something that multiplies with negative 84 and adds to negative 17. That combination is negative 21 times 4, or negative 21 plus 4. All right? So I write my equation as 0 equals x minus 21, x plus 4. To solve this equation, we set each of our factors equal to the 0. And we have x equals 21, x equals negative 4. Now we get two solutions here. These two solutions are valid. They are okay. We said x can't be negative 7 and 0. Well, all right, I didn't get those answers, so I'm okay. X is 21, and x is also negative 4. I have two solutions there. So x can be either one of those. All right? This, again, relates to problems 5 and 6 on your homework. The last thing I want to mention to you guys about your homework is on problem 6, little quick tip for you guys. As you're working, problem 6, you're going to want to start off by factoring this problem to be 3 over x plus 1 times x plus 1. That should help you guys out a little bit to start that problem. All right? Message me if you guys need any help on any of these problems. Your homework tonight will be the 6 practice problems at the end of these notes.